The Production Planner is a web application designed to streamline the sales to shipping process in manufacturing environments, bridging the gap between sales, production, and shipping teams. This application was built for a small electrical instrument manufacturer. In their previous workflow, the sales to shipping process involved several periods of waiting for information and then rushing to complete the task once information became available. Whereas with the Production Planner, teams have access to a continuous flow of information, offering smoother operations, better team coordination, and enhanced customer service. Here is the original sales to shipping workflow prior to the introduction of the Production Planner. Throughout the day, the sales team would receive orders and enter them into the QuickBooks accounting software. In the morning, a daily open order report would be printed for the production team, along with packing slips for the intended orders for that day. The production team would review the orders against the current inventory and prepare the orders which could be shipped. The packing slips for orders which were not able to be shipped would be discarded or set aside. The dimensions and weight of each package would be written on the printed order report, and once all of the orders were ready, the report would be scanned to a shared folder for the shipping team. Once the scan was seen by the shipping team, they would then prepare the waybills and documents for each shipment. And in the afternoon, pickups would be made by different couriers, and any order which was not ready before the pickup would be delayed. Now here is the workflow sequence following the implementation of the Production Planner. The sales team enters new orders into QuickBooks as they are received throughout the day. The production team can confirm or delay new orders as they are added, and once an order has been confirmed, then the packing slip can be printed. Orders can be prepared one at a time, with dimensions and weight information added as they go. The shipping team can immediately see when order information gets added and prepare the shipping documents as early as possible for the day's pickup. After contrasting the two versions of the workflow, it is clear that there are many benefits to the continuous flow of information that the Production Planner offers. For the sales team, they no longer need to create and physically print the order report every day, which is not only less work, but less resources, less potential for paperwork to get lost, and less reliance on printers which sometimes malfunction. There is also improved customer service because customers can be notified sooner in the event of a delay. For the production team, benefits include more efficient batching of production tasks and less manual quoting of orders, as the dimensions and weight can be predicted based on previous order data. For the shipping team, less mistakes are made due to handwritten package dimensions, which sometimes can be hard to read. Also, the package information can be directly copy-pasted into QuickBooks sales order notes. The continuous flow of information also means that they no longer have to wait for all of the orders to be ready before receiving the dimensions and weight information, which means that they have a more even pace of work with less rushing and less costly mistakes. Taking a look at the specific features of this application, we'll start with the Open Orders page, which is optimized for tablet screen viewing and intended mainly for the production team. Through this interface, users can filter orders by date or status, search for an order by its reference number or customer name, confirm the shipping date of each order or mark orders as delayed if there is not enough inventory, add the dimensions and weight for each package. If an identical order has already been shipped, then suggested dimensions and weight can be used or discarded. They can add notes about the order, mark the order as ready once it has been packed and is ready for pickup, and once the order is marked as shipped, it is removed from the Open Orders page. While the Open Orders page is intended for the production team, the All Orders page is intended more for the sales and shipping teams and optimized for a desktop screen. Here the information and features are mainly the same, but on this page you can see both the shipped and non-shipped orders. There's also the ability to change the ship date for an order or change the shipped status in case it was accidentally marked as shipped on the Open Orders page. The main reason for separating these features into two pages is to limit errors and display data in a way that integrates best with each team's workflow. Last, there is the home page. The last update tells the user when the last change was made in QuickBooks, and the green dot signifies whether the connection between QuickBooks and the Production Planner is active. If the connection has been closed for more than 2 minutes, the dot will turn gray. The Add Order page allows users to manually add an order. It can also quote the dimensions and weight of an order if the same combination of items has already been shipped. If there are no suggested dimensions available, the user can mark it as a quote and it will appear on the Open Orders page for the production team to estimate. Finally, there is the Dimensions page, which allows users to add or remove package dimensions, which then become available in the drop-down list of dimensions on the Open Orders page. This app can be started by double-clicking the Start App file. This file can be left running in the background indefinitely and will automatically fetch updates every 60 seconds from QuickBooks during the operational hours set in the scheduler file. If the script needs to be stopped, for example, if a user has to enter QuickBooks in single user mode, the connection to QuickBooks can be closed with the Stop App file, which will keep the rest of the app's functionality running, just without any updates from QuickBooks. The application's sync with QuickBooks can easily be restarted by running the Start App file again, or if the user only needs a one-time sync, they can directly run the sync data file. There's also an automatic database backup that occurs every weekday morning, and the 10 most recent backups are saved in the Database Backups folder. If the database needs to be restored, it can be done by executing the Restore Database to Latest Backup file, and the database will instantly be restored to the most recent backup. A manual backup can also be created at any time by double-clicking the backup database file. If an error occurs, like if the connection to QuickBooks is not able to be established or if the scheduled backup encounters a problem, then an email is automatically sent to the administrator with a copy of the error log for easy troubleshooting. This project features a Django backend, a React frontend, and a MySQL database. All this is encapsulated within a Docker container, and a series of Windows batch scripts trigger the data retrieval from QuickBooks and data entry into the application's database. When the Start App batch file runs, it triggers a Python script which creates a log file to ensure that only one instance of the script is running at any time. And then it goes through a series of error checks, like checking if QuickBooks is open and logged in and whether Docker is running. If Docker is not running, or if any of the images are stopped, then it will open and start the container, and then run the checks again. If a critical error occurs, a notification email will be sent to the administrator with a copy of the error log. If the error checks pass, then the script will check if it is within the operational hours, and if it is, then it will trigger a script to check QuickBooks every 60 seconds. Within this time frame, the error checks will also be triggered once every hour. The Check QuickBooks Python script connects to QuickBooks' ODBC database, which is configured by the QODBC driver and queries the database for open sales order information. The order data is then added to a JSON file, and another script is triggered which adds the data to Production Planner's database. This script runs every 60 seconds, so to speed up the process, instead of checking the Production Planner database for each order's existence, there is a second JSON file with each order's number and time-modified value from QuickBooks. If the order number is in the JSON file and the time-modified value has not changed since the last sync, then the script ignores that order. But if the order has been modified since the last sync, or if the order is not in the JSON file, then it will go on to check if the order is in the database. If the order number is not in the database, then we can assume it is a new order and go ahead and add it. However, if the order number already exists within the database, then we must determine whether the existing order requires an update or if the situation involves a back order and a new order entry must be created. This logic may require a bit of familiarity with how QuickBooks handles back orders, but here's the function in plain English about how that aspect is resolved. Basically, when an order contains a back order, if it is partially invoiced, then the order item quantities change, but the order number stays the same for all iterations of the back order. This makes it difficult to differentiate whether an update has been made to an order or if it has been partially shipped, so it's important to check the previously invoiced quantity to handle order updates properly. Once the order table has been updated with the current order data from QuickBooks, then the JSON file containing each order's time-modified value is updated. This is so that during the next sync, the script can identify which orders to process. If any changes are made to the order table, then an entry in the last update table is also updated with the current date and time. This approach is efficient for keeping data in the front end current because instead of scanning the entire order table for changes, the backend only needs to check this single field, and then if that field has changed, it will trigger the updated order data to be pushed to the front end. This process is handled by a view function, which initiates an event stream to monitor the last update field at 2-minute intervals. Most of the other views are pretty straightforward, but some notable features include the sorting function, which handles the date, type, and search filters in the front end, and the implementation of pagination, which makes data retrieval on the All Orders page faster and more efficient. Regarding the database models, some interesting features include the indexing of important fields and hashing. The indexing for order number helps during the initial data entry, the shipped index helps quickly populate the open orders page, and the hashing is useful because it speeds up the process for identifying matching item arrays and quickly provides suggested dimensions in the front end. Looking at the front end, several components are reused throughout the pages, like the navigation filters or the error modals, which handle API and user-generated errors. However, the majority are specific to each page's functionality. UseState and UseEffect hooks ensure that the UI is always in sync with the underlying data and allow multiple users to modify information simultaneously without having to refresh the page between changes. Axios is used for handling asynchronous HTTP requests to communicate with the backend, and server-side events keep the user interface up to date with the latest database changes without manual refreshes. There's pagination implemented on the All Orders page because this page is expected to accumulate a lot of data over time. Lastly, since users may be navigating between pages often, the filter settings are saved in the browser, so that each user can keep their preferences set without having to constantly reselect or experience interference in their data selection from other users. In terms of improvements, this app has a lot that could be refined. In the README, there is a section for all the to-dos, but in its current state, I think the highest priority updates would be for the front end to break down some of the more complicated components into smaller subcomponents, and also to merge the existing variations of error and confirmation modals so that they become one singular modal, which would itself be a little more complex, but easier to modify universally. Regarding the backend, it would be more consistent if everything was in the UTC time zone, with the user-specific time zone specified in one singular place, and then dates and times would ideally be reformatted in the front end. Overall, the production planner is a big improvement to the original sales to shipping workflow, enhancing efficiency, coordination, and customer service with its real-time information flow and easy integration into daily operations.